So this was the equation. If I compare it with simple wave equation, so you can see our wave equation is like this: v uxx minus 1 by v square utt is equal to 0, correct? This is our classical wave equation. So this in free space is comparable to this. And the solution of these equations are in the form of sine and cosine. So I will write the solution of this also in the same way. If your del square you want to write in Cartesian, then you will have plane wave solutions. And if you want to write the del square in spherical polar, then you will have a spherical wave coming out, spherical wave. And if you want to write del square, depending on the system, in cylindrical coordinates, then you will have cylindrical wave. So like in class 12th, you have read about wave fronts, the spherical wavefront, cylindrical wavefront. Okay, so you can compare it with that: spherical wavefront, cylindrical wavefront, like that. Okay, so अभी थोड़ा सा सिंपल केस अगर ले लें, जस्ट टू अंडरस्टैंड. सो ये कैसी वेव होती है? क्लासिकल वेव. कोई डैम्पिंग टर्म नहीं है, कोई फोर्स टर्म नहीं है, तो जस्ट फ्री ऑसिलेशंस की वजह से जनरेटेड वेव है. ओके, सो बिल्कुल सिमिलर पैटर्न पे अगर मैं बहुत ही सिंपल केस ले लूं, फॉर एग्जांपल, I consider that my wave is propagating in z direction, and the profile may be written as E is equal to E naught cos of kx minus omega t plus delta. Okay, okay, so this is the profile of electric field. मैंने जो simple cos लिख दिया, cos profile kx minus omega t, you know, that is the solution of the wave equation. Okay, so this is plane wave solution, and I will put here kz, and if I write the profile of B, it will be B naught cos of kz minus omega t plus delta. This will be the magnetic field profile, because same equation we will have for magnetic field. अगर आपको याद हो, del square B minus 1 by c square del 2 E by del T2 is equal to 0. Okay,
Yes, sir.
now if you see from the equation, del cross E is equal to minus del B by del T. If I just want to see the directions, just take the Fourier transformation, it will become ik cross A is equal to what I will get here?
Sir, j omega
Minus, so it will become minus I omega into B, correct? So this cancels. So k cross E is equal to omega B. Yes or no?
Yes, sir.
K
Yes.
for the plane wave, k cross E is equal to omega B, right? So that means if k is the propagation direction, yesterday somebody was asking this, if K is the propagation direction and E is the electric field, so take K cross E, it will be this. This will be the direction of magnetic field, correct?
Yes, sir.
So just by taking the Fourier transformation, you may get this. K cross E is equal to omega B. So this formula we can use for the plane waves. Whenever one quantity or two quantities are given, we can calculate the third one. And from here, we can also see that K dot E will be equal to 0, which is the first Maxwell's equation. And also K dot B is equal to 0. K dot B is also equal to 0. Second Maxwell's equation. Okay? So this is a very straightforward result जो हमने अभी तक किया है. ये नोट कर लिया ना सबने नीचे तक?
Yes, sir.
तो मैं यहाँ पे सिंप्लिसिटी के लिए ये सॉल्यूशंस आपसे कह रहा हूं कि इसको मैं z ले लूं, z कैप, तो ये क्या हो जाएगा? x कैप, और ये क्या हो जाएगा?
Y cap.
y कैप. एक बार जरा देख लेना. ओके?
Yes, sir.
सो यहाँ पे इफ आई पुट वेक्टर, इट विल बिकम x कैप, और अगर यहां मुझे वेक्टर लिखना होगा तो इट विल बिकम y कैप. So this is how electric field and magnetic field will be propagating. So you have this as a propagation direction, and then you have profile of electric field, profile of magnetic field. Both are moving perpendicular to each other and perpendicular to the direction of propagation. Changing electric field is producing magnetic field, which is in phase with this. Changing magnetic field will produce electric field, which is in phase with this, and both are moving. So this is how electromagnetic waves are produced. और इनमें हर क्वांटिटी आपको पता है, k is just wave vector, it is 2 pi by lambda, and omega is 2 pi f, and delta is called phase. Okay? So अगर in general मैं इस E को plot करूं, तो I will have to plot it like this, correct? Yes? So suppose this is snapshot at t is equal to 0. So this term goes, and then you have at z is equal to 0, you have this is equal to delta. So this is E, and this is say kz. With respect to kz I have plotted. So ये क्या हो जाएगा? This will become delta. तो इस केस में दोनों वैक्यूम में जब चलेंगे, they will be in phase with each other. ये समझ आ गया सबको?
Yes, sir. सर ये इन फेज समझ नहीं है.
इन फेज मतलब जैसे ऐसा होता है, फेज का क्या मतलब होता है कि जैसे सपोज एक क्वांटिटी ऊपर जा रही है, एक क्वांटिटी की वैल्यू बढ़ रही है और दूसरे की उसी समय घट रही हो, तो ये दोनों आउट ऑफ फेज हो गए ना. ओके?
Yes.
तो वेव के केस में देखो, अगर बहुत सिंपल डायग्राम बनाऊं, तो सपोज ये 3 डायमेंशनल है, तो मैं ऐसे बनाऊं, मान लो इलेक्ट्रिक फील्ड को, तो मैग्नेटिक फील्ड विल बी लाइक दिस. ओके? So this will be electric field and this will be magnetic field. Are you getting it? This will be electric field and this will be magnetic. ये दोनों perpendicular हैं वेक्टर्स एक दूसरे के. So ऐसा नहीं होगा कि जैसे यहाँ पे देखो ये दोनों बिल्कुल फेज में चल रहे हैं, जब ये बढ़ रहा है तब ये भी बढ़ रहा है, फिर ये कम हो रहा है तो ये भी कम हो रहा है, फिर यहाँ ये मीट कर रहे हैं, फिर आगे ऐसा ही होगा. इट विल नेवर हैपन दैट दोनों के बीच में फेज डिफरेंस आ जाए. ओके? और ऐसा भी तो हो सकता है लाइक इन द केस ऑफ करंट, यू नो वोल्टेज और करंट में फेज डिफरेंस रहता है इन द केस
Yes,
ऑफ इंडक्टर एंड इन द केस ऑफ
I will
कैपेसिटर.
take it.
सो दैट इज नॉट द केस हियर. ठीक है.
Yes, sir. मतलब सेम फेज से.
सेम फेज में देखो ना, दोनों का डिफरेंस लो तो जीरो आ जाएगा, इसको माइनस दिस कर लो, यू विल गेट जीरो. ओके. ठीक.
Yes,
नाउ सी. अब ये जो वेव वैक्यूम में चल रही है, इलेक्ट्रोमैग्नेटिक वेव प्रोपोगेटिंग इन वैक्यूम, व्हाट इज द डिफरेंट टर्म्स that we can calculate? So first one is electrostatic energy density. अगर आपको याद हो, so it was half epsilon naught E
yes,
squared. Remember this?
yes.
What will be the unit of this, Puneet?
Joule per meter cube.
जूल पर मीटर क्यूब. अब देखो कितनी सिंपल, अगर मैथ्स आती है, अदरवाइज ये सब चीजें देखने में लगता है कि पता नहीं क्या कर टफनेस है. You have to just simply put UE is equal to half epsilon naught. E square will be E naught square cos square kz minus omega t plus delta, right? Electrostatic energy.
Yes, sir.
So electrostatic energy is just oscillating. You can see cos term is there na. So with time it is oscillating. So मान लो आपकी salary daily अलग अलग है, and at the end of the month somebody asks you what is your salary. So how you will tell? मान लो daily आपकी earning different है.
Average.
Hmm?
Average. Average बताएंगे.
Average. So the simple thing what we do is we write the average value of it because it is oscillating value. So we will write average of this and this will become half. Okay.
Yes, sir.
So this will become 1 by 4 epsilon naught E naught square, where I have used that average of cos square theta is equal to half. Similarly, if I write the average of for this wave propagating in vacuum, if I want to write average of magnetic energy density, it was 1 by 2 mu naught. Yes.
B.
P square. So it will be equal to UB is equal to 1 by 2 mu naught. What will be this? B naught square into 2, half. Correct?
Yes, sir.
So this will be equal to 1 by 4 mu naught into B naught square. यहां तक देखो समझ आ गया सबको? Yes or no?
Yes.
बिल्कुल सिंपल मैथ्स है. Okay. And when you want to calculate total energy densities, that is UE plus UB, let us write it by U. So it will be equal to 1 by 4 epsilon naught E naught square plus 1 by 4 mu naught, and B naught will be, so you know B naught will be E naught by C in vacuum. So this will become E naught squared by C square. Right?
Yes, sir.
And now you can see C square was just 1 by mu naught epsilon naught. Yes or no?
Yes, sir.
So this will become U is equal to 1 by 2 epsilon naught E naught square. If you want average value, this is the answer for electromagnetic wave propagating in the vacuum. So this is that part of energy. हमने पावर को दो पार्ट में डिवाइड किया था अगर आपको याद हो. So एक पार्ट था electrostatics and magnetostatics और दूसरा पार्ट था that was leaking out in the form of pointing vector. So this is the first part. सबको समझ आ रहा है?
Yes. Yes, sir.
This is okay ना? K cross E is equal to कितना था? Omega B. This was perpendicular, so KE will be equal to omega B. So E by B is equal to omega by K. Yes, which is equal to C.
C.
Is it okay?
Yes, sir.
Yes, sir.
Now let us calculate the now the energy corresponding to pointing vector. So what was S is equal to pointing vector 1
1
by
by
mu naught
E cross B.
E cross B. So this S will be 1 by mu naught EB sine 90. Yes or no?
Yes, sir.
And if you want to put vector, it will be in the z cap direction. Energy will be transported in that direction, in the direction of K, right? So this will become 1 by mu naught E naught B naught cos square kx minus omega t plus delta, right? This is the value of S. So if you
KZ, na?
kz, sorry, kz. I have taken propagation in z direction. So average of S will be 1 by mu naught E naught B naught into 1 by 2. Correct?
Yes, sir.
So this will be 1 by 2. This is B naught is E naught C. So E naught square C. सही लिखा हुआ है? By mu naught. चेक करते रहना.
Yes, sir.
Is it okay?
Sir, E naught by C होगा.
Hmm?
Sir, E naught by C equals to B naught.
नहीं B naught की जगह मैं oh sorry मैंने ये गलत लिख दिया.
Yes, sir.
It will be C. हाँ?
Yes, sir.
So mu naught C कितना हो जाएगा? It will be 1 by epsilon naught C. Hmm? So this will become 1 by 2 epsilon naught C E naught square will be average pointing vector. And you know what is the dimension of pointing vector? Watt per meter square.
Yes, sir.
So what per meter square means? This is also known as intensity. क्या कहते हैं इसको? Intensity. So this is also called intensity. So this is average value of Poynting vector. So on an average, how much energy will flow out of the surface which is surrounded by a volume V, in which that energy जो previous मैंने लिखा है that is contained, we have derived that. So ये बता रहा है कि per unit area per unit time कितनी energy leak हो रही है. Okay? How much energy is leaking per unit area per unit time. Please see this. Is it okay?
Yes.
Yes, sir.
So when electromagnetic wave travels, this much intensity is transported. मतलब जब electromagnetic wave travel करती है तो उसके साथ इतनी इंटेंसिटी ट्रांसपोर्ट हो रही है. अगर कोई रास्ते में कोई ऑब्जेक्ट आएगा तो इस इंटेंसिटी के साथ उस पर टकराएगी. ओके?
Yes, sir.
We can calculate few other quantities also.
सर वो जो अंदर का जो एनर्जी है
हम्म
इलेक्ट्रोमैग्नेटिक एनर्जी वो
हम्म.
सर अंदर में ही रहेगा, वो नहीं, कोई इफेक्ट नहीं करेगा जब
जैसे तुम कोई वॉल्यूम कंटेंट अज्यूम करो. ओके? और सपोज इलेक्ट्रोमैग्नेटिक वेव आ रही है, यहाँ पे कोई वॉल्यूम तुम कंटेंट ऐसे मानो. ठीक है? कोई भी वॉल्यूम मान लो. तो इस वॉल्यूम में कितनी एनर्जी कंटेन्ड है और बाहर कितनी एनर्जी जाएगी. ओके? दोनों तुमने कैलकुलेट कर लिया.
इस
ओके? तो कुल मिला के कंजर्वेशन ऑफ एनर्जी तो लगना ही है ना.
हाँ
So the momentum carried by the electromagnetic wave P is given by S by C square. Okay? The momentum is given by S by C square. So if on an average we calculate the momentum, how much we will get? Average momentum, it will be average S by C square, and this is equal to, ये कितना था?
Epsilon naught
E naught
square by
C
2c.
half E naught C E naught square.
So what it will become? 1
Sir,
by
epsilon naught.
1 by 2c
Yes, sir.
epsilon naught
E naught square.
E naught square. So this will be the momentum imparted on an average, because S we have already calculated. So this is the momentum imparted. Okay?
Yes, sir.
Now we can also, suppose wave is traveling and we put some surface. So we can see how much force we feel, because momentum we have got. So what is force?
Rate
Force
of change
is
of momentum.
TP
so I will start from here, that we have formula for what? We have formula for momentum. अभी हमने क्या क्या कैलकुलेट कर लिया? S कैलकुलेट कर लिया, इंटेंसिटी कैलकुलेट कर लिया ना.
Yes, sir.
Yes.
Intensity was calculated and momentum was calculated, and now you want to see if I want to calculate pressure, suppose, so next likho radiation pressure. Okay, next I want to calculate radiation pressure. What is radiation pressure? Like this is radiation, electromagnetic wave, it is traveling, और जब भी रास्ते में कोई ऑब्स्टिकल आएगा, so it will put some pressure on it. That pressure is called radiation pressure. Okay,
Yes, sir.
ठीक है. So pressure से पहले force निकालना होगा. It will be momentum by time, rate of change of momentum. Yes,
Yes.
Yes, sir.
and this what we have calculated is momentum density. ये क्या है? Dimensionally भी देख लो, हर चीज per unit volume में थी ना.
Yes, sir.
So if you want to calculate momentum, you will have to see certain volume just to see the momentum. So let me take this as area A and this as distance, that will be C delta T. Distance is equal to speed into time. Okay. So this will be equal to momentum density will be equal to, likho jara, momentum 1 by 2C epsilon naught E naught square into volume. Volume will be A C delta T. देखो समझ आ रहा है? This is
Yes,
volume.
sir.
So this will become by delta T. So this will cancel. Yes. And force will become, force by area will become how much? C and C will also cancel now. 1 by 2 epsilon naught E naught square.
सर
Hmm.
सर पॉइंटिंग वेक्टर जो एस हमने निकाला था वो तो एरिया में था ना, पर यूनिट एरिया में.
हाँ,
वॉल्यूम में कैसे सर?
मतलब तुम ये जानना चाहते हो कि ये कैसे मोमेंटम पर यूनिट वॉल्यूम है.
यस सर.
ओके, सो एस का डायमेंशन क्या था?
वॉट पर मीटर स्क्वायर.
पावर
पर मीटर स्क्वायर.
पर यूनिट एरिया.
यस सर.
पावर पर यूनिट एरिया. ओके, इंटेंसिटी है ये.
यस सर.
ठीक है, और डिवाइडेड बाय क्या है? सी. तो इट इज बेसिकली पावर into AC square. Okay, what is power? Joule per second upon area into what is this? Meter square per second square. Second and second cancels. Okay, now what is this joule? Joule is m L square T to the power minus 2. Okay, and into 1 T na upon L square. This is area na, and this is L to the power 4. So L square, L square. So L square cancels. So it will become M L square T to the power minus 1. Okay. So
Sir,
which
L to
is,
the power -2.
sorry,
Sir, L to the power -2.
L to the power,
सर वो डिवाइडेड बाय एल स्क्वायर।
एक मिनट कहीं गलत हो गया शायद, जस्ट अ सेकेंड, थोड़ा और सिंपल तरीके से करता हूँ। ये है मोमेंटम डेंसिटी, तो इसको लिख लेते हैं हाँ हाँ ठीक है, ओके। सो व्हाट इज S इज इक्वल टू, इट इज वॉट पर मीटर स्क्वायर, एंड व्हाट इज दिस, मीटर स्क्वायर सेकेंड स्क्वायर। अभी सही है?
Yes, sir.
Now it will become what will become joule or per second, and into second square by meter square into meter square. So meter cube I want, so just take 1 meter here and put it cube here. Is it okay? And just remove this. So we want here momentum. So momentum यहाँ पे लिखा हुआ है. Now it is okay. This is joule second by meter into meter cube. So we have to just prove that this is momentum. Okay. So energy into second क्या होगा?
सर एनर्जी बाय वेलोसिटी तो मोमेंटम ही होता है।
एनर्जी बाय वेलोसिटी ना, तो इसको ऐसे लिख देता हूं. ओके, सो दिस इज मोमेंटम, एनर्जी बाय वेलोसिटी. सो दिस इज मोमेंटम per meter cube, that means momentum density. Okay, you can check it by yourself. ठीक है भाई?
Yes, sir.
So this is very important result. Please check this. This is called radiation pressure. क्या कहते हैं इसको? Radiation
pressure,
pressure. So radiation pressure is equal to 1 by 2 epsilon naught E naught square. What was intensity?
Sir, इसी को C से multiply कर दूंगा.
So what was intensity? So radiation pressure
Multiplied
will
by
be equal to what?
intensity multiply. So,
No, intensity divide by
intensity divided by C.
C. This is very important formula. So if it is falling on a surface which can absorb this, right? Then it will be
Yes, sir.
this. क्योंकि जो तुमने momentum change निकाला है, उसमें initial momentum, final momentum absorb हो गई radiation, ठीक है? और अगर perfect reflector है, reflector, then radiation pressure will become 2 times IC. बिकॉज यू नो चेंज इन मोमेंटम, जैसे mv इधर आ रहा है और टकरा के वापस जाता है -mv, तो क्या हो जाता है? चेंज इन मोमेंटम 2 times mv. ओके, सो इफ इट इज अ रिफ्लेक्टर इट विल बिकम 2 times ऑफ दिस I by C. देखो समझ आ रहा है?
सर नीचे वाला चेंज इन प्रेशर,
सॉरी,
नीचे जो है वो चेंज इन प्रेशर है।
ये किसने बोला भाई? ये भी रेडिएशन प्रेशर है, ये भी. ये एब्जॉर्बर के लिए है. सामने जो चीज आ रही है वो अगर लाइट को एब्जॉर्ब कर लेती है तो दिस विल बी द रेडिएशन प्रेशर, और अगर परफेक्ट रिफ्लेक्टर है तो दिस विल बी द रेडिएशन प्रेशर. So it will depend on the surface. Okay.
ओके।
ये समझ नहीं आया क्या जो मैंने mv और माइनस mv से समझाया?
हाँ हाँ
सो प्लीज स्क्वायर ब्रैकेट में रखो क्वांटिटीज कौन कौन सी? कौन कौन सी?
एवरेज एनर्जी, एवरेज
एवरेज इलेक्ट्रोस्टैटिक एनर्जी, एवरेज मैग्नेटोस्टैटिक एनर्जी, एवरेज टोटल एनर्जी, देन
इंटेंसिटी,
intensity means s,
एवरेज एस,
average s, then average momentum, then
रेडिएशन।
radius. सबको नंबर करो जरा 1 2 3 4. Put it in square brackets and then number them. कर लिया?
Yes, sir.
Yes.
Then we can just calculate a quantity called wave impedance. Wave impedance. So like impedance, you know, when combined effect of capacitance, inductance, and resistance is there, we call it impedance. So impedance is general term for resistance, right? Resistance is used for a particular case, that is resistor. But any behavior, any resistance like behavior will happen, so that we can call impedance. So impedance की unit क्या होगी? Ohm. Okay. So in vacuum, we define impedance is equal to E naught by H naught. I mean the amplitudes. ठीक है? वेव तो ऑसिलेट कर रहा है बट उसका एम्पलीट्यूड फिक्स होता है, राइट? सो दिस विल बी, ये याद है आपको, बी नॉट क्या होता है? म्यू नॉट एच.
Yes, sir.
So this will become Z naught is equal to E naught by H naught की जगह क्या रख दूं? B naught mu naught. Okay. So this will become E naught by B naught क्या होगा? C.
C, sir.
So C mu naught, and this C mu naught is equal to
1/epsilon.
So you can put it like this also, 1 over
Epsilon naught, sir.
no, not 1 over 1 upon mu naught by epsilon naught. Okay. And when you put it, it will become 120 pi. So this is the impedance of electromagnetic wave, because dimensionally you will see that this quantity is resistance dimensionally. So this is 120 ohm. यहाँ पे जब C put करोगे तो क्या आएगा? C square is this, ना? 1 by, sorry, C is this 1 by mu naught epsilon naught. Okay.
120 pi होता है.
सर वो 125 है क्या?
C square, na?
Yes, sir.
So when you put C mu naught, so you will get this. Okay. C की वैल्यू क्या हो जाएगी? 1 by under root mu naught epsilon naught. So when you put it there, it will become mu naught into 1 upon under root mu naught epsilon naught. So this will become under root of mu naught by epsilon naught. Okay. So what is mu naught? Under root of mu naught by 4 pi. Can I write it like this? Upon एप्सिलॉन नॉट को 4 पाई एप्सिलॉन नॉट divided by 4 pi. Is it okay?
Yes, sir.
So it will become 4 pi cancels. No. Just इसको ऐसे रहने दो. 4 pi. Then what will happen? So it will become under root of, ये कितना होता है म्यू नॉट बाई 4 पाई 10 to the power minus 7 into 1 upon 4 pi epsilon naught
9 into 10 to the power
9 into 10 to the power 9 and यहाँ पे क्या आ जाएगा 4 square pi square, right?
Yes.
So it will
Yes, sir.
become 4 pi 10 3 120 pi ohm. समझ आ गया?
Yes, sir.
So this is called impedance of electromagnetic wave in free space. This quantity has the dimension of resistance. इसका dimension किसके equal है? Resistance. Okay?
Yes, sir.
Can you prove this? कि इसका dimension resistance के equal है?
Yes, sir. Sir,
Can-
eco sir Brad भी लिख सकते हैं।
E को VD लिख लो ना?
हाँ, VD
वोल्टेज
And,
इनटू और नीचे जो H है उसको करंट में लिख लो, राइट?
current by R. Yes.
So you can write it like this. E नॉट को लिख लो VD अपॉन H क्या होता था याद है? H into distance was equal to I, right?
Yes, sir.
हाँ, जब इंटीग्रल करते थे ना मॉडिफाइड एम्पियर्स आई मीन एम्पियर्स लॉ इन H लिखते थे.
Sir,
this
E equal to V by D होता है। V equal to ED.
V is equal or E is equal to V by D. V by D into what was H? I by D.
I by D.
So DD cancel, it becomes resistance. Okay?
Yes, sir.
So even this is अभी तो नहीं इतना आसान आता है, but sometimes back even this was the question that what is the impedance of electromagnetic wave traveling in free space. So now this is okay? समझ आ रहा है सबको?
Yes.
Yes, sir.
So एक थोड़ा सा कवर करना पड़ेगा, then we can go for questions. Okay? थोड़ा सा पहले topics कवर करने होंगे. So like next one is electromagnetic wave traveling in a medium. Traveling in a medium. So our Maxwell's equations will be modified, correct? Del dot D will be equal to 0. Del dot B will be equal to 0. Then del cross B, del cross B is minus del E by del T. And del cross, sorry, पहले वो लिखना चाहिए था. Del cross E
Del cross E.
is minus del B by del T, and del cross B is mu naught epsilon naught del E by del T. Correct? So
That
if
will
you
be-
change it, it will become B is equal to mu H and D is equal to epsilon E. Okay? So this equation will be modified by डेल क्रॉस, बोलो भाई,
Del cross
H
H equals to
H into mu, हाँ,
yes
is
sir.
equal to mu नॉट एप्सिलॉन नॉट E की जगह D by epsilon, so del D by del T. Okay, so del cross H is equal to 1 by mu, यहां आ जाएगा ना, mu by mu naught and epsilon by epsilon naught. Can you see that? Del D by del T.
Yes sir.
And what will be situation here? So this will be del cross H is equal to 1 by mu r epsilon r del D by del T. Okay. तो जो चीज यहाँ म्यू नॉट एप्सिलॉन नॉट थी वो यहाँ क्या बन गई भाई, B जब H में चेंज हुआ तो रेसिप्रोकल हो गया, बट दे आर इक्विवेलेंट. कैन यू सी दैट?
Yes sir.
So now in previous case you had suppose electric field like this. This time it will be some V square del 2 E by del T2 if you write it in E. Okay, you can see this transition. So what was C in previous case? 1 by root mu naught epsilon naught. This time this wave will be traveling with velocity V, that is equal to 1 by under root mu r mu and epsilon. Is it okay?
Yes sir.
So this will be the change that is going to happen. So जो पहले वैक्यूम में kc by omega जब तुम कर रहे थे तो it was 1, याद है? In vacuum this was 1. Now this time when you will do kc by omega in medium, you will find under root mu r epsilon r. All right, and this is called small n and this is called refractive index. इसी को क्या कहते हैं? रिफ्रैक्टिव इंडेक्स. तो बिल्कुल सिमिट्री से तुम देखो इक्वेशन लिख सकते हो. यहाँ म्यू नॉट एप्सिलॉन नॉट इन वैक्यूम था और म्यू और एप्सिलॉन, दिस इज परमिटिविटी ऑफ द मीडियम and this is magnetic permeability of the medium. All right, so you can see, you can compare that your velocity will become c by n. You can use this to get this result. This is what happens when electromagnetic wave goes into the medium. The velocity reduces by n times, where n is refractive index. समझ आ रहा है या नहीं?
Yes sir.
तो अब थोड़ा और अलग अलग मीडियम जैसे कंडक्टर, प्लाज्मा, ये सब लेके देखना पड़ेगा हमें कि जब वेव उसमें प्रोपोगेट करती है तो व्हाट विल हैपन. यहां तक कोई डाउट हो तो बताओ. एनी डाउट? चलो कोई नहीं. तो अभी 1-2 क्लास लगेगा, we will cover the topics and then we will be able to solve questions because they are interrelated ना, so we have to cover that much. Okay, चलो, thank you so
सर
much.
मेरा
हाँ
एक बेसिक डाउट है
हाँ
सर, इस फ्री स्पेस में जब वेव ट्रैवल करते हैं
हम्म
तो उसमें कोई डिक्रीज एनर्जी डिक्रीज क्यों नहीं करता है, मतलब इनफाइनाइट
तुम खुद देख लो जो क्या कहते हैं एवरेज एनर्जी कैरीड बाय द वेव है, उसमें कोई एटीन्यूएशन फैक्टर है जो उसको कम करे?
हाँ सर, वो क्यों नहीं आ रहा है सर, मतलब एनर्जी इनफाइनाइट तक ही जा रहा है।
तो मैथमेटिकली नहीं आ रहा है ना, मैथमेटिकली दैट इज नॉट कमिंग. ओके